Hello YouTube. So the last video actually did quite well. I got a bunch of feedback and I thought it was quite positive. So I am gonna continue with an episode 2. We're basically gonna finish up the project with the repository. So if I look inside the internal folder, we have event, models, repository, server. See, repository wouldn't actually be in this directory. I'm not sure why I put it there. But you basically have like your features here. So we've got models where we'll have all our models. We've got a server where we have a handler and a server. And then we have event. So inside event, we would have a repository specific to the event. So looking at the use case, we've got a find by ID method. And here we're just hard coding a value. But realistically, this would call a repository to go into the specified database, whether it's Postgres, whether it's Mongo, to get the user against the ID. So this use case is basically sort of the use case without the database specific logic. Here we would call the repository.find by ID, for example, and you can also do some additional logic after and before. So this is a good way of separating the sort of use case logic from all the query against the database logic. So enough theory, we're just gonna make it so it's more understandable, because it's hard explaining code a lot of the time, so I feel like it's best we just get into this and get this made. But before we do get it made, we will actually need a database. So if we head over to Docker. So guys, here I am on Docker. I currently have a little Stripe demo going on, which I will be doing a project for very soon. So basically, Docker has images, and I've got a Postgres image. This has come from the internet. It's basically downloaded it locally, so it can basically recreate loads of Postgres containers from this image. Obviously the tag is the type, so the version. 12 Alpine is basically a minimal Linux version of Postgres. As you can see, it's only 368 meg. So the Linux server literally just has Postgres on it. So how do we spin up a container? Well, you can basically write a YAML file. This might be the easiest way in terms of project related. So we'll write a YAML file where we can just run one command and it will spin it up, and we can run one command and it will spin it down. So back to our project here. So in the root, and it will have to be in the root, you're going to have to make a file called docker compose.yaml. And inside this folder, you declare all your services with services. And you can call your services whatever you want. Obviously, in this case, you can call it Postgres or DB. And you do need to define the image. And the image for this one is Postgres 12 Alpine. And then we need to call it a name. So obviously we're grabbing an image, but we do need to call it a name for the container. I'm just going to call it Postgres here. Then we're going to add the ports. So you add the ports like this. And I'll explain this. So basically the Linux server opens up the port 5432, and this is on the left side. If you were not to put this right side here, so if you weren't to put any of the ports even, then you wouldn't be able to connect to it locally, because your computer does not attach an instance onto that port. So 5432 on the right side is your local, and you're basically saying map it to this Linux server. So the 5432 on your port goes to the 5432 on the Linux server. And we'll see that in action in a second. So we now want restart always, and that means if we do come into any errors, it will restart. And we need an environment. And the first thing is Postgres_user, and we're going to call it Postgres. Now I did forget a dash here. Okay, and the next one's password. Obviously you can have whatever you want, but this is also going to be Postgres for me. And the last one is DB. Now this is related to the project, so I'm just going to call it demo. Okay, so the next step would be to spin this up. With this, we can then do docker compose up, and if we hit up now, I'll actually show you this. Your terminal's going to be flooded. So that's because my terminal has now become the Linux's terminal. If we Control C here, I'm going to clear this. If we do a -D, it then does it in the background. There we go. So the terminal's perfectly fine. Now if I go to Docker, so you see here, Golang tutorial, we've got the Postgres instance, there we go. Now I'll explain the DB part actually after this, but yeah, so you see the ports we're forwarding, so our localhost 5432 attaches to the Postgres, so that's where you get your connection. And you can see the image, we didn't make a new image because we're just using the one that we have here, so I can spin up many of these against the one downloaded image. If I do click on Postgres, you're going to see all of the logs for the Postgres server. And now I'll show you how to spin this down. So we're going to come over to the terminal and do docker compose down, and that effectively removes it. We'll spin it back up now. The first thing I want to talk about is this DB. Imagine you have microservices. This is a bit more advanced, but imagine you have microservices and you want to basically communicate to another service. You would have to use the DB on the connection. So imagine you'd have to go HTTP and then you'd do DB. Basically, that's how that would work. So if you're making a reverse proxy and you want to direct your traffic to different services, you would have to use DB as the host name. Okay, so the first package we're going to be talking about is Go Migrate. So I've just searched Go Migrate into Google, and you'll see this top one here. So on your computer, you're going to want to have this installed. So for most people, you guys will be using this link here, so go get, and then this in the terminal, and that will be able to, that will basically allow you to use the migrate tool. But for Mac users, we can use Homebrew, and it will just be brew install, and then it will be Golang migrate. So to demonstrate this on Mac, we just do brew install Golang migrate, and there we have it. So now I can do a migrations folder first. So we're going to go to our root. I'm going to have a migrations folder, and I'm going to extend this window real quick, and I'm going to do migration create sequential extension.sql and then we'll point to the migrations folder, then we'll say create event table. Okay, it's not migration, it's migrate, my bad. So we'll come back here, migrate. Okay, and then in the migrations you get an up and a down. So the down will be drop table if exists event and the up is going to be create table if not exists event, and in our case we have an ID, big serial, primary key, and we have a name, or I think it's a title, text, not null. And to demonstrate this, I'm going to create a connection string as a environment variable. So just blowing out on my keys here, I have a demo db dsn environment variable on Mac. You will either want to copy this and figure out how to do it on Windows if you are on Windows, but essentially all it is a connection string using this format. It's like a little URL. You will need SSL mode disabled, and you should be able to connect locally wherever you, say if you're using PG admin, you'll just need to type that in, or I'm sure PG admin probably does this for you. I'm pretty sure you just need to connect to localhost with the port 5432. I can then source my variables, so I do this, and now I should be able to echo the demo dbsn string, and you can see it right there. So to migrate, you would do migrate, and then you would do the path. So this is migrations. Then you would do the database, and that is that variable we saved. So it would be demo db dsn, and then you would say up, or you can say down, and in this case we want it up. And I have got a syntax error. That's because you can't have a trailing comma. And now here's a good example of how to fix this. So right now we have a dirty database version, which means it's tried to apply a migration, but it hasn't managed to do so. So obviously with pgadmin, you would find the schema table. So for me, I can do dt, I can see my tables. So we've only got one table, and it's called schema migrations. Now I want to select all from schema migrations, and I can see dirty is true. Now you would roll back the version and dirty, because the version is now 1, it should be 0. So in my case, I don't actually have anything in the database, so I'm just going to remove this table. So I'm going to do drop table schema migrations. There we go. Now if we go dt, we've got no tables. I'm going to X out of that with the \q, and we can run this again, and you can see we've created an event table. So if I go into the PSQL, I can do select all from users, or sorry, event. Don't know why I thought users. There we go. So we've got an event table, and it has an ID and a title. So the next step would be to connect our project to that database. Now there's many ways we can do this. We can pass a connection string for a flag, etc, etc, but for this example I am just going to hard code this in. So we will be making a new file, and this will exist inside of our package, and inside of here we're going to call it db, and then inside of here we're going to call it Postgres, because you would hold all of your database types here. So inside of Postgres we're going to make a db_con.go, and we are going to need a few packages, and I'll get them now. Okay, so back to the terminal. I'm going to be getting a package, so we're going to say go get here, and okay, I did copy a go get with it, but this is basically so we can do like db query row, db exec row, stuff like that, except we're getting a version called SQLX, which means we can do a struct scan. That's the most beneficial piece of this package I've seen so far, and that basically allows us not to type as much as we would have to. So I'm just going to get this package. There we go. Okay, so once we've got SQLX installed, we can go ahead and complete this file. So we're going to make a func new Postgres DB. So this is sort of like a factory for our database. And we would accept config stuff for the connection string, but for now we're not. So in this case, we will return in SQLX.db and an error. And then we need to create our connection string. So we will do constr equals fmt.sprintf, and we will do host port user pass. So this will be password, DB name, and SSL mode equals disable even. Now we will have to pass all of these here, but in this case we're just going to hard code it, so it'll be localhost port 5432 Postgres and the database name in my case is demo, and that should be enough. So we now have our connection string format, and it will have to be in this format for the driver we are using. So if I now go to DB, so you'll see SQLX here. So we need SQLX, and we just need the connect function, which accepts a driver name, driver source, and a string. So our driver name is actually going to be PGX, and our connection string is here, and this is going to return a database object and an error. So we're just going to do db error, and here we're going to do if error is not equal to nil. We're then going to have to return this error, so return nil and the error. Otherwise we can return the database and nil. So you might see nothing wrong with this code at the moment, but this is going to fall into a few errors. So if I go back to main, and the server will want an instance. So real quick, we're just going to add a DB here, SQLX DB, because we will need to pass this to a repository which the server will instantiate. So if we go into CMD API main here, we're going to want to create a database. So we're going to do the Postgres.new Postgres, and we're going to say db error, and then we're going to do if error not equal to nil, panic. So we'll just panic for now because this is a detrimental piece of our project, and if the database doesn't work, we don't want the API to work. And then of course when we create a new server, we're going to need to pass in this db instance, so sqlx.db on the new server. So back to main, I'm just going to pass in database, and there we go. So now the server, if we go here, okay, it doesn't really show me, but the server now has that database aspect. So we might see nothing wrong with that, but there is still something we need to include. We do need to import the driver inside of our DB Connect. So up here, we're going to need a import, and I'll just get this one sec. So the import we need is as follows, and you can type this out, but it's just github.com/jackc/pgx/standard library. So from here, we basically have the driver installed, so this should work. Okay, so I'm back. I'm not sure why that wasn't working. I did have a Postgres user set up on the Postgres database, but I've just switched out the connection string to the one I know works for now, which you can still just fmt sprintf this format, but I thought it would be a lot cleaner. If you guys got it working, that's good. In other projects, it works perfectly fine, so I'm really not sure about that. It might just be a bad database spin up. Maybe I'll have to spin it down, spin it back up. But yeah, moving on anyway. We have that connection and we passed it now to our database. So the next steps will be to create the repository, which is our main goal of this episode. Create the repository to separate that concern and actually have some live data to mess with now. So if I go into first we want to go to the handler, because that's where it all starts, and you'll see here we are finding by ID and we're passing that ID, and we do get the ID from the parameter, and obviously if we don't get it back we return a not found. So if we go into this ID here, that's the shape of it, and if we go to the use case here, this is our logic. So we are going to have to separate this logic. So for now I'm just going to return nil and errors dot new unable to find user. Okay, so right now we're going to want to go into repository and we're going to have to make a pg repository dot go. So the reason I said pg repository dot go is because we might eventually do a little bit of stuff with Mongo and have the same methods and stuff. It's just a different connection and also it's going to be different logic inside. So we're going to want to create a type called repository, so we'll call it event repository here, struct, and we're also going to want to go back out here into the main event root folder and create a repository dot go, and in here we're going to package event and we're going to do type repository and then interface. There we go. And here we already know our function is going to be find by ID, and we're going to take this ID, so ID in 64, and we're going to return a user. So no, an event, sorry, I'm not sure why I'm thinking of user. Yeah, so we're going to return an event or an error. So if I go into the repository now, we're going to want to implement that. So first we are going to need to pass in a database, otherwise we won't be able to run the query. So I'll just remove this here, and when we instantiate it via the new event repository and return not a pointer because it's going to be an interface, so event repository, we're going to return the event repository with a db SQLX that we get from the server. And obviously it's going to complain because we don't have that method. So if we do here R for a repository, event repository, and we do find by ID, and we take in that ID and we return out the event or an error. Now here I'm just going to return nil nil, it's not going to get any complaints. So just back at the use case, we're going to sort of implement around the repository as though we have already created the logic for it. So we know we're going to get an event or an error back from the repository, and we're going to have to pass this in here. So repo, and this will be an event. So actually it'll be a event repository, and here we're going to do repo event repository, and here we're going to do repo. So I hope you guys are starting to see how it all works, how it all comes together, all the shape, you know, the structure. We'll look on an overview on the server, but yeah, you will eventually get the structure, and you can create many features and just extend from this. But once you've learned this feature, your code will look a lot cleaner, hence the name Clean Architecture. So we're going to do urepo find by ID, it's right there, and we're going to pass in the ID that we get, and obviously if error not equal to nil, we're going to return a nil and an error. Otherwise, we can return the event. So very simple scenario here just for the demo, but you could have a lot more logic inside of this use case that you can't have in the repository, because the repository is purely just the query. So we're going to go back to the repository, and the way we do a query is quite simple, but we are going to extend on top of that. So we're going to first create an event object. So the way we do that is here, and so it'll be an event models event. So we've instantiated a new event object, and we're also going to want some arguments. And the only argument we actually need, I'm going to do this anyway because you guys want to know how to store arguments, and you basically create any array and store them like this, and you'll see this in use. So if I go r.db, we'll have plenty of options, but the one we want, because we are going to get data back, is a query, and then we only want one row, so it'll be a row, and we want the x for the SQLX and context. So x context, and if you look, so we require a context. This is so if we can basically say set an amount of time for it to run, and if it exceeds that time, then it will cancel, it will throw an error basically. So the way we create context is here, so it basically returns a context and then a cancellation method. So we can do context dot with timeout, and we can do a default one, a background, and then we can do a time.second times 5, so that's 5 seconds, and we will have to defer the cancel, so at the end of this method it will cancel out. And here we're going to do ctx, and we need to write some SQL for a statement, and we can do that at the top. So statement backticks allow multiple lines, and we can do select all from event where ID equals, and then $1 is a placeholder. You can have many placeholders, so we can do and email, for example, if we maybe had an email for the event, or maybe host name, and then we could do $2, for example. And that's what I was saying with the args. You'd store your arguments here, and then you basically pass in your statement here, and then you do a split operator here to spread out the arguments, and this returns an error, but we need to scan, so struct scan, which I forgot the X here, so struct scan, and we can scan it into an event. Now for this to work, we are going to want to basically JSON and DB annotate our objects. So for JSON, I want it to be like that, and for database, I know it's like that. So you need to map this up with what you have in your migrations. So for example here, I can see ID, but I also have a title here. So same again. So when the struct scan looks at your objects, it's going to be like, oh, okay, so we've got a So a DB annotation with ID. So anything called ID in the database, we're going to map to this field in the memory. So if we go back to PG repository here, that should now work. And we just need to handle the error. So error not equal to nil. We're actually going to return nil and the error. Otherwise down here we're going to pass the event. There we go. That's as detailed as it gets in terms of like complexity. Obviously you're gonna have your different queries, maybe you insert into, like, you know, all of this sort of stuff. Maybe you'd have like inner joins, etc, etc, but it all comes down to this pattern and functionality. All of the logic is completely interchangeable. So if we go to use case, we're just going to look over the use case, and yeah, it looks alright. So now we're going to check we've got no errors here, and we have got an error because we forgot to basically instantiate this repository. So we're going to say event repo, and we're going to do repository dot new event repository, and this requires a DB. There we go. And this requires the event repository. Perfect. So now we've got that sort of like pattern, and I'll show you this now. The entry point is the handler, which requires a use case. So we have to do the use case before the handler, and then the use case will require a repository. So we'll have to do the repositories before the use cases. So it sort of works backwards in a way. And you'll obviously have many of these. So eventually you might want to push it out into a different method. So so map handlers might call map repositories, map use cases, etc, etc. So, but this is basically the structure you'll go for, passing it down, and then obviously you have your routes, which then have access to all of this through the handler. So we're just going to run our project, and it works perfectly fine. So I'm just going to spin up a new instance on the terminal, and we're going to do a curl -i http localhost 4000 API v1 events, and then let's try and hit 1. We haven't got anything in the database, so this is going to throw an error. Not the error I was expecting though. Okay, so there was a few mistakes made. So your DB, you guys probably saw this as we went along, but new server, we did pass in the DB, but we didn't actually bind it to the new reference of the server. And if we look in main, we also need to remember to defer close after we have created the database. But simple issue. And on the right, we have a message not found with status 404. Okay, so I'm on a separate terminal, and if we go to the database, so PSQL demo, so first I will have to source, and if we do PSQL demo DBSR, there we go, and if I do select all from event, it might be events, nope, event, yeah, so we selected all from event, we have nothing. So first thing I'm going to do, I'm going to do a manual insert into event, and we're going to do ID, title, actually we don't need the ID, so just title, then we're going to do values, and here I'm just going to do example event. So of course without double quotes, kind of double quotes in Postgres, so example event, and you can see this has worked. So now if I go back here and we curl again, we're going to get that back. So it hasn't bound properly, So looking at our repository, this is because we're not actually, so I did do select all before on camera. This would have worked for you guys if we go here and I'll just restart the server. This works, so you guys would have got a correct message, but if you were to extend your database further with more fields and stuff, if you don't want inconsistencies in data coming back, you will want to restrict this by doing the ID and title here. So if I restart the server, I now get it back. Perfect. So that is the completion of the entire pattern for the most part. Obviously in packages you would just go ahead and install more packages, such as like your analytics, your logging, stuff like that. Migrations you would obviously extend, you'd get more migrations, you'd be able to, you know, control how your database like scaffolds in a way. And then your internal has all of your features, so if you had auth, you would put an auth folder here. If you had anything really, to be honest, anything to do with your app that's a feature that would have a handler, it would have a use case, it would have a repository, this would all exist here. And then obviously CMD would hold your, basically the root like entry of your project. So here we've got API, but say you have a website, you'd have web. Say you had a gRPC sort of entry connection, you'd have gRPC. It is all extendable in this nice folder structure. And I hope you guys enjoyed this second part of the tutorial. There was a bit more errors involved this time. With databases, it's never 100% smooth, but I hope you guys learned something from these 2 episodes. The last one got a lot of traction, so I'm happy about that. And I do want to do some full project on camera, so that'll be quite nice, a little course where it's literally a full project that we can even push to deployment, because I have messed around with DigitalOcean deployment and I am happy to go through that on camera and discuss, you know, how we would create an actual product and ship it. So guys, that'll be all for this video. I hope you guys liked it. If you did, a like would be helpful. I got plenty of likes in the last one and super happy about that. So yeah, I'll see you in the next one, and that should be a Stripe integration tutorial, which is going to be a bit more advanced, but it'll be very, very fun to implement. And hopefully if you guys ever want to make a project where you do accept payments, this will come in handy for sure. Okay guys, see you next time.